Okay, I'm documenting this before I pull it apart and do some other things today. So we're driving this in a configuration where the plus and minus of the e-bike come into each side of this, and then there's a join wire to join both bifilar primaries together, so they're pulsing as one unit, like an isolation transformer, but they're not isolated because the ends come onto here and then into the other bifilar windings, more like an auto transformer, and then they spit out to these two chokes. There's a diode before the positive side choke, and then that carries on to the cell. The clicking you hear is this relay which is firing. We've got the connection to the relay is sitting across the isolation transformer in parallel, so as the pulses come in to the transformer, there's a little bit of spare, pulls that contactor, and the contactor, the normally closed contactor, is being pulled open. So what that will do is, if I short, where is it? If I short this guy to that diode there, we're going to see a short circuit on every, at the tail of every pulse. Just here, it's going to clamp the cell right down to the ground state. So I'll show you that now. So this is the cell being shorted on every time. I don't know why it's got a little bounce in there. Does it make a difference to the gas production? It doesn't seem to look like it is. So does it affect the current draw? No. I was using it on this large bulb here. I'll do that after we do the small bulb. We'll do the little bulb first. So we've seen it pull down at full short circuit, and so this, why is that not showing? Oh, it fell off. So that's with that small wheat bulb. That's 100 milliamp, I'm pretty sure, 100 milliamp 12 volt wheat bulb. So that's not even lighting at all. So let's connect to this one and show you that. Okay, so I've got that one on there now, and that's pulling down with that 35 watt filament. There's no glow in there, there's nothing to see. There's what it looks like on the screen. There's a little bit, it's almost all the way down. If we're looking at that, we'll just look in there, and I'll just take it off while we're watching. So it's still on now, and I've removed it. So we'll just see if we think there's any increase in gas. It's hard to quantify that. Maybe a tiny bit more. Okay, reconnecting. Yeah, maybe a tiny bit more, and it hasn't affected the current draw. Right, I'll put a LED on here now. Okay, so now we've got the LED on there. It's out of sync to the pulsing because of the camera frame rate. But curiously, didn't we need pulsing LEDs that are out of phase to the cell power, because that's being powered in that zone there. So in theory, couldn't I use this light to make the gas more reactive? Is there anything else I wanted to show you while I was here? Oh yeah, I'm going to make an isolation transformer today. I just wanted to show you the amazing, let's turn that off. Oh, and I should also demonstrate to you that I am at the point of it almost clicking. If I go too far, if I back it off, I can get it to not click, and then there'll be a random click every now and again, pulling it down. Or off altogether, and that's just a function of how much power's going in on each pulse. And look at that, that's still coasting along. Alright, yeah, so the ferrite, check this out. You see the gap there in this ferrite, it's meant to be gapped, there was a little gap in there. But look what happens every time they touch. So I was wondering if you put like a rubber gap in there with a tiny little like silver button in the middle of the rubber, if you could get it to, like, the silver button be just a little bit skinnier than the rubber, and then you could get this to, on every cycle, you could get it to make the ferrites connect together. Alright, that's where I'm at. Thanks for watching. Don't forget to comment if you got any comments, and thumbs up and all that. Share, you know how it goes.